Let g be the function given by g of x equals x squared times e to the kx, where k is a constant. For what value of k does g have a critical point at x equals 2/3? So we have this constant k in this function for g of x, and we need to find out what k should equal so that g of x has a critical point at x equals 2/3, meaning for what value of k does g prime of x equals 0 when x equals 2/3? So to solve for this k, we can first find the derivative, g prime of x. So here we have two functions of x, x squared, and e raised to the kx, so we'll have to do some product rule. So we'll multiply x squared with the derivative of e to the kx, which is just k times e to the kx, because the derivative of e raised to some power x is just equal to that e raised to that constant times x, but then we have to multiply by the derivative of that power, and the derivative of kx is just k. So k is the chain rule piece. And then we have to add to that the derivative of x squared, which is 2x, multiplied with e to the kx. So that's the power rule, product rule for finding the derivative. So we can simplify this a little. G prime of x just equals kx squared e to the kx plus 2 times x e to the kx. So now what we need to do is find the value of k where g prime of x at an x value of 2/3 equals 0. Because we know that critical points are points of a function where its derivative, so in this case g prime, is equal to 0. So let's plug in 2/3 into our g prime and solve for the value of k. So we'll have g prime of 2/3 is equal to k times 2/3 squared. So that's going to be 4/9 times e raised to the k times x. So that's just going to be 2/3 k plus 2 times 2/3. This is x is 2/3 times e raised to the k times x, so 2/3 k. So let's simplify this. G of 2/3 is 4/9 k e to the 2/3 k plus 4/3 e to the 2/3 k. Okay. So now that this is the value of g prime at x equals 2/3, we can simplify this one further step by taking some factors common out. So this is just going to be the last step of simplification before we've solved the value of k. So we can take out a 4/3 and a e raised to the 2/3 k from each of the two terms, this term here and this term here. So on the first term, we'll be left with 1/3 times k, and the second term will just be a 1 because this literally is the second term. 4/3 e to the 2/3 k. And we know that we want a value of k such that g prime of x equals 0 when x equals 2/3. Because that means at 2/3, x equals 2/3 is a critical point. So let's set this equal to 0. So we need to find a value of k, and when we plug into this, we get 0. And if we look at our equation here, we basically have two terms. This term out here with the e, and this inside the parentheses. Now, if we look at this e term here, just by our knowledge of the exponential function, we know that this can never equal 0. There's no value of k, no value of this exponent that will give us a value of 0 from our exponential function, because we know if we plug in 0 for k, we'll just have a 0 in the numerator and the exponent, and anything raised to the 0th power is just equal to 1. And if we put in something negative, that'll just have e raised to some negative power, 1 over e. And that's not equal to 0 either. So the only solutions we're going to get are from when this term here is equal to 0. Because when what's inside this parentheses equals 0, then whatever is multiplied by 0 is just 0. So let's look at this here. We have 1/3 k plus 1. And to see when this term equals 0, we can set this equal to 0. So we'll have 1/3 k equals -1 if we move this to the other side. And then let's multiply both sides by 3. So we'll get k equals -3. So what it's saying here is that when k equals -3, g prime of 2/3 is equal to 0. So this is our value of k. When k equals -3, the derivative of g of x, g prime of x, is equal to 0 at x equals 2/3. So the correct value of k is -3, which is answer choice A.